Let's find the area between the functions 2x and x squared minus x between x is equal to -2 and x is equal to 3. And as always, it's probably a good idea to sketch the functions. The first function, 2x. So it's a straight line passing through the origin with the slope of 2. So it kind of looks like the slope is 1, but that's just because this is formatted differently. It seems sort of stretched in the y-axis, but that's 2 units for 1 unit of movement. So that is a slope of 2. All right, that's our f of x. G of x, x squared minus x. So what is that? I could factor that as x minus 1 times x. So I've got 2 zeros at 0 and another one at 1. So that's going to look something like, where's the bottom? So g prime of x is 2x minus 1. That's going to have a 0 at x is equal to, what is that, 1/2? So right there is going to be the bottom. And if I plug in 1/2 into this, I get 1/4 minus 1/2. So 1/4 minus 2/4 is minus 1/4. So there's 1, there's a half, there's a fourth. All right, again, super bad at art, but it gives us the right idea. Okay. Let's see. We want to find the area between these two functions between x is equal to -2 and x is equal to 3. So there's -2, and it will eventually run into my function. And I want to go until x is equal to 3. So again, it will eventually run into my function. Okay, so we've got a couple different areas here. So when we think about which function is on top, I think it's going to switch on us. Let's see. If we want to find this area, right, because eventually that area is bounded. Okay, so notice here in area 1, it's the square function that's on top. So for area 1, that is going to be the integral from -2 up until they cross, so at 0. And it's the square function that's on top, so it's the g of x minus f of x, right? That gives me these lengths, right? The value of g of x, which is the square function, minus f of x, the straight line. All right, and then I need to keep going. I need to add this area. So I need to add, how much area is here? In area 2, we'll call it. So it's definitely going to be the integral from 0 up to whatever that point is right there. And I don't think we have figured that out yet. So the question is, where do these two functions intersect? Where is x squared minus x going to be the same as 2x? So x squared minus 2x minus x is equal to 0. X squared minus 3x is equal to 0. So x times x minus 3 is 0. So 0 is one of the places that they intersect, but we already knew that. Right? They crossed at the origin. The other point is 3. Oh, yeah, so I did not do a very good job at this at all. That intersection is supposed to be all the way over here. Right? So let's clean that up a little bit. Actually, the straight line was good. It's probably the quadratic. There we go. So actually, I don't have 3 regions. I just have 2 regions. That puts me at 3. Okay, so I can integrate all of the rest of the way, all the way to 3, and it's the straight line that's on top of the quadratic. So it is the f of x minus the g of x that gives me these lengths, or these heights. Right, so then I integrate those heights to give me the area. All right, let's see. Now that we know what we're doing, I think it's almost time to just do it, except I need to go back and amend what I've written down. I need to make sure that I remember my dx. There we go. That should give me the area. And I think we're ready to do it. So the integral from -2 to 0, g of x is x squared minus x. F of x is 2x. And we'll add to that the second region from 0 to 3, where f of x is the function on top. And again, remember, distribute that negative. All right, so we get x squared minus 3x. And we get 3x minus x squared. Oh, it makes sense that we got the negative of each other because we just switched the order f of x minus g of x or g of x minus f of x. All right, let's find antiderivatives. So this is going to be 1/3 x cubed minus 3/2 x evaluated from -2 to 0 plus 3/2 x squared. Oh, oops. That's supposed to be squared, isn't it? Yeah. 3/2 x squared minus 1/3 x cubed evaluated from 0 to 3. Okay, let's work on this guy first. If you plug 0 there for your x's, you just get 0. If you plug in -2, what are we going to get? As a decimal, you get -8.667. All right, the next difference. So if I plug in 3 into that antiderivative, I get as a decimal 3.33. And when I subtract that antiderivative at 0, I just get a 0. So we get 8.667 plus 3.33. That's going to give us a, what, 8.667 plus 0.33 gives us a 9. 9 plus 3 gives us a 12. So that's how much area is between those two functions, between x is equal to -2 and x is equal to 3.